Hello everybody, it's Mr. Chase. We're working on chapter 15 in our science book on digestion and excretion. We're on lesson 2 today, the digestive system, so let's go. All right, here are the key concepts. What does the digestive system do? We're going to go into detail, a little bit of detail. There's a lot more to it than we have time to talk about in this class, but we're going to get the overview of what the digestive system does. How do the parts of the digestive system work together? And more importantly, what are those parts and how do they work together? How does the digestive system interact with other systems? As you saw in chapter 14, and we'll see pretty much in every chapter about the body's systems all work with other systems to keep us alive, to do different things. So, and it's everything that is interconnected, and the proper function of each system is really vital to an organism, that's us, to human survival. So here's your vocabulary for this lesson: digestion, mechanical digestion, so you'll need to know the difference, and chemical digestion. So 3 kinds of digestion: the overall concept of digestion, and then the 2 specific types, and we will talk about that in this presentation. What an enzyme is, what it does, what the esophagus is and what it does, a piece of anatomy that's very important. What peristalsis is, peristalsis, you should be able to say that word correctly. And chyme, you should also be able to say that word correctly. I believe it has a Greek origin, and that's why it's pronounced chyme. And villi. I'm going to play the lady speaking who will say villus, because that's a single villi is a villus, which you should have said villi because that's the actual word. But here we go.
Villus, a finger-like projection, many of which cover the folds of the small intestine.
All right, so obviously very small, finger-like, microscopically small piece of finger-like thing, not at all large like our fingers, but finger-like. What are the functions? So what does the digestive system do? What does it do? So when we eat food, which all of you do, it goes through 4 steps. So you obviously need to know these 4 steps, and this is something where you want to know them in order: ingestion, digestion, absorption, and elimination. So we'll talk about each stage. Ingestion is the act of eating, or putting food in your mouth and chewing it. So that's how we all survive. Digestion is the mechanical, so that's physical, and chemical breakdown of food into smaller particles and actually molecules that your body can absorb and use. So we're getting down to the molecular level, very small. Digestion comes from digestus, which means to separate or divide. So you're breaking down food into smaller parts, dividing it essentially. Nutrients, which we learned about in lesson 1, the 6 different kinds of nutrients, or actually 5 and water if you consider it separate, in the food are absorbed as small molecules, again, back to that molecular level of digested food, by cells in the digestive system. We'll talk about what cells specifically here in a little bit. Undigested food is eliminated, obviously, with other waste from your body. So what does the digestive system do? Should have some notion of that it breaks down food into smaller and smaller particles until it finally gets down to the molecular structures that we can absorb. Hey, back to what is digestion? What are the 2 different types, and how do they differ, and how are they the same? Mechanical digestion, food, is physically broken down into smaller pieces. Okay, mechanical digestion, again, the same concept, happens when you chew, mash, or grind food with your teeth and tongue. So the tongue helps kind of move the food around and form what's called a bolus, which is a small amount of food kind of in almost like a ball-like structure that moves through the system. Okay, so now we're moving from mechanical digestion to chemical, the 2 different kinds of digestion. In chemical digestion, chemicals, which we produce, chemical reactions break down food into small molecules. Again, back down to that molecular level. So it breaks those nutrients down to their smallest format in molecules that then can be absorbed into our bodies and used. Enzymes, okay? Enzymes are a specific type of protein that helps break down larger molecules into smaller molecules. A great wonder question would be, what are those enzymes? Which we'll talk about a few of them. But also, what are those larger molecules, and how are they getting broke down into smaller molecules? Like, how does that work? And what do you call those larger molecules? I actually don't know, so we need to look that up. Enzymes also speed up or catalyze, that's that word, catalyze the rate of chemical reactions. So if I ask you what catalyze means, you should say speed up, because it's right there in the sentence. So it means speed up or catalyze, same thing. Okay, so it helps speed up those reactions so that we can digest food faster and more efficiently. Just think if we didn't have those enzymes, it would take a much longer time to break down food, and it might not break down at all. It would make digestion a lot slower. So speeds it up, makes it more efficient. The digestive system produces enzymes that are specialized to help break down each type of food molecule. So another wonder question would be, what are those food molecules? How many are there? The specific enzymes pepsin and papain, I believe that's how you say it, help break down proteins. So we talked about proteins in the nutrient section in lesson 1, and here we are talking about them again. And remember, there's carbohydrates, fats, and several other kinds of nutrients, vitamins and minerals. They all need to be broken down so they can be absorbed. Fats, okay, one of the nutrients, are broken down with the help of the enzyme lipase, right? And you should be familiar with that first part, the root of this word, lip. We talked about lipids, which are fats, and lipase, which helps break down fats. Kind of makes sense. Those have a similar root. So step 1, the enzyme attaches to the food particle. You can see here on the screen. The enzyme speeds up that chemical reaction. It breaks the food particle down, and you see the top sort of beige tan thing getting broken down into smaller parts, and then it releases that broken down food particle. So the enzyme doesn't stay attached. It does its job, and then it releases, which kind of gets into a great wonder question like, I wonder how that works. It'd be really fascinating to watch it happen. Okay, back to the organs now, the physical structure of the digestive system. You definitely want to be familiar with these. 2 parts, basically. The digestive tract itself, which is like a long tube, essentially, where food breaks down, and then the other organs that support that digestion. So they're not in the tube, but they're attached to it. These organs include the other organs, not the digestive tract. These other organs include the tongue, salivary glands in your mouth, right? That's where you make saliva. The liver, down lower, the gallbladder, kind of close to the liver, and the pancreas also just behind the liver. The digestive tract extends from the mouth to the anus and has different organs connected by tube-like structures. The whole thing, again, is like a giant tube that starts at the back of your throat, at your mouth, and then goes down through the various organs, which we're going to talk about. All right, so mechanical digestion, again, that breakdown, physical breakdown of food into smaller chunks and eventually into a bolus. Your teeth and tongue mechanically digest as you chew. So they're breaking down the food, and the digestion process starts in the mouth, starts right away. Oops. Saliva, the sort of stuff you're secreting all the time, contains an enzyme that helps break down carbohydrates. You hopefully will remember from lesson 1 that carbohydrates are the energy source for our body, and so that it starts breaking that down right away because we need it. And substances that neutralize acidic food. So when you eat something acidic like an orange or tangerine, some of those citrusy things, or other foods that are acidic, it helps neutralize it so it doesn't damage our body or upset the stomach. Okay, so we move from the mouth then to the esophagus, the tube that runs to the stomach. And it's a muscular tube. That's important. So it's not just like a garden hose that's just flat and stays flat. So if you think about it, if you ate food and it just dropped in that tube, it would like hit your stomach really hard and just keep hitting it and just slide right through. But that's not what it's like. It's more narrow. It's more almost like a stocking that's really tight and that you have to squeeze through. Or like the hoses, they kind of pull in on themselves. So it's constricted until the food gets into it, and then the muscles will contract in an organized way to move the food along slowly. All right, so it moves in a progressive way. And it connects the mouth, obviously, to the stomach. So we go from mouth, esophagus, and now to the stomach. So food moves through the esophagus and the rest of the digestive system by waves of contractions called peristalsis. Please make sure you know how to say that word, peristalsis. And again, that's that organized contraction of muscles all the way through the system that moves the food along in whatever form it is. And when you think about it, it's really great that that is an involuntary muscle that works. You don't have to think about digesting food. It just happens automatically. Imagine what it would be like if every time you ate, you had to stop and think, okay, let me fire off the esophagus in order, get it right, and now I got to contract my stomach and kind of keep doing that, and the intestines and everything, and you had to constantly think about moving those muscles. It's all you would be able to think about all day. So it's wonderful that that all happens without having to think about it. This diagram here of the body, you do want to know these parts. Most of them, several of them you should already be familiar with. Obviously the stomach, esophagus might be sort of new, but you know the mouth and the tongue. That's something you should already know. Large intestine, small intestine, hopefully you are a little bit familiar with. So really, you're just talking about the stomach, the pancreas, gallbladder, and liver maybe, and the salivary glands. That might be sort of new. And then the rectum, the official word for the end of the intestines. And here you see, and again, it's really hard to model this in a still picture, so this picture is not moving, but imagine that the tube is squeezing, the esophagus is moving along in kind of an organized squeezing manner. That would be an accurate depiction of what's really happening. Okay, so we're moving to the stomach, which is that large hollow organ that temporarily stores food and aids in chemical digestion. So by the time that food bolus hits your stomach, it's already softened up and kind of blobby, and then it's going to get more chemicals introduced in your stomach and kind of sit there for a while, and the digestion is going to continue there. It contains gastric juice, which sounds funny to me. Almost sounds like orange juice, apple juice, gastric juice. So be like, oh, let's drink that. Ugh, gross. But anyway, so it makes that acid that helps break down cells and food. So we're getting from sort of pieces and particles to that bolus, and now we're starting to break down food into cells. Gastric juice also contains the enzyme pepsin, which helps break down proteins. Notice those words both start with P. Pepsin breaks down protein. Food mixes with gastric juice, we talked about that, in the stomach to form now a thin watery liquid. So that food is broken down enough to where it's in kind of a liquid mush called chyme. That's the official name for mush, chyme. All right, so here's your stomach. You see the food coming in at the top through the esophagus, which make sure you know that word and what it does and where it connects. All right, so it's coming down in a bolus, kind of a blobby thing, soft blob, and then it hits the stomach, which is going to squeeze it through using that peristalsis motion, and then it's going to mix it up, kind of churn it up with those gastric juices, which definitely do not drink them. Ick. All right, so it's kind of hard to see in the picture, I think, if you look close, and it's probably a good picture in your book. The folds in the stomach enable the stomach to expand. If you think about the stomach kind of like a balloon, that's probably the best analogy, but the balloon deflates and inflates and deflates and inflates. And you know with a balloon, and when you first get it, it's sort of all squished together and it's not at all stretched. But the stomach then will expand and stretch, and because the tissue is there, it sort of ends up being all foldy and scrunchy until you expand it, almost like a raisin that's been dried out, but it keeps rehydrating and reinflating into a grape. That's essentially what the stomach does. All right, then the food, after it's been mushed with gastric juices, will end through the bottom of the stomach and flow into the small intestines first. Again, knowing the order: mouth, esophagus, stomach, small intestines, and then of course the large intestines after that. So chemical digestion of proteins, carbohydrates, nucleic acids, new term there, might want to look that up, and fats takes place in the first part of the small intestine called the duodenum. I think that's how you say it. I'll have to double check that. Duodenum. Okay, so that's the first part of the small intestine. It actually has a name for that section of that first section. So we have some breakdown, some absorption happening here. And the remainder of the small intestine absorbs nutrients from food. And that again gets back to lesson 1. Those 6 nutrients are 5 plus water, carbohydrates, fats, proteins, vitamins and minerals, that stuff. Okay, so that's why we learned that. Hopefully you learned it. So now you know what it's actually breaking down food into is those nutrients. The folds of the small intestine are covered with finger-like projections. Again, I love that. Called villi. You see the kind of the I's and the L's make it almost look like little finger-like things. This diagram here that you see on your screen: liver, gallbladder, pancreas, small intestine, stomach, esophagus kind of up there, large intestine, and rectum. You should be familiar with this, right? For the quiz and the test and just knowing what you're supposed to learn. All right, so this is now getting kind of digging in closer to what's happening in the small intestine, and it's really they'll blow up the villi. You kind of see it looks like almost like a carpet here, and then we're getting into like what the actual little fingers look like and what's inside them. So when you look at an actual villus, again, there's hundreds of thousands of these. interesting to find out kind of if there's an estimate on how many we have in our small intestines. But you see the blood vessels there are right there inside the villi, okay, as well as the lymph vessel. So what's happening is that food's getting absorbed, or the nutrients rather, excuse me, are getting absorbed through the villi into the actual blood system, or the blood, which is part of the circulatory system, which I don't think we haven't learned about that to my knowledge. You guys haven't. So that's another body system, is the circulatory of blood and heart, veins and arteries, all that stuff is the circulatory system. And I think we'll learn about that in a future chapter. All right. So now you've got these nutrients in the small intestine, and they go straight, they absorb by the villi straight into the blood system, the blood vessels, circulatory system through the blood vessels. The pancreas and liver, and again, those are those side organs kind of on the right side of our body, next to the stomach or close proximity to the stomach and intestines. And the liver produce substances that help with that chemical digestion, right? We had the mechanical, and now we're into the chemical in the lower part of the digestive tract. They put this in here. I'm not sure this is super worth knowing, but science use matter that makes up a particular chemical makeup. In other words, it has a consistent chemical makeup. It's called a substance. And that substance is consistently at the chemical level, the molecular levels consistently the same. In common use, it just means a fundamental quality. So I'm just kind of read that and move on. Food not absorbed in the small intestine moves by, again, that peristalsis, now it's kind of sideways, into the large intestine, also called the colon. And when people have a colonoscopy, they check out the colon to make sure it's okay and there's no cancer and stuff like that, and it's functioning. So, a little side note. Materials that pass through the large intestine are waste products of digestion and the body. And then muscles in the rectum and anus control the release of the semi-solid waste called feces. That's the official name, scientific name for poop. All right, some bacteria digest food and produce important vitamins and amino acids. So this right here, I wish we could spend some time, like a fair amount of time, talking about this. It's a relatively new field, I believe, in terms of figuring out what exact bacteria in the body is helpful. And our bodies are called biomes because they're a living system of things, including bacteria. And so there's a lot of questions about the bacteria that we have in our bodies and of what effect it can have on us. There's some indication that it can actually affect mental health if you have certain types or lack certain types of bacteria. So super interesting field of research, and I wish we could spend more time on just that. Also of note, when we take antibiotics for anything, when we have some sort of a bacterial infection and we take antibiotics, a lot of times that antibiotics will just sort of wipe out a lot of the good bacteria that you need in your system. And so then it has to build back up. And that would be a great wonder question. Like, how do we do that? And what happens if you take antibiotics too long or too often? What happens to those good bacteria? Is it even possible to rebuild the healthy bacteria? And what happens when you don't or can't? All right, nutrients absorbed by the body through the digestive system are necessary for other body systems to maintain what we've called homeostasis, or just a steady state of survival and living. What might happen to other body systems if the digestive system did not function properly? This is worth thinking about all kinds of different ways and could lead to some awesome wonder questions. Like, I wonder how long people can go without eating before something permanently bad happens, right? That's a great question. What systems break down first? What's essential? One of the things, obviously, we learned about the skeletal system. What would happen if you didn't ingest enough calcium, right? That's a mineral. Your body doesn't produce it. It needs it. So you have to ingest it. What would happen if you don't? You should know from that lesson, that chapter, that the bones would become brittle. And also then your heart actually would not function properly because calcium, it turns out, is essential for muscles and particularly the heart to fire properly. All right, enzymes in the digestive system break down food. Again, the enzymes don't change, but the food does. The molecules change, and it breaks it down into nutrients, so it can be absorbed by the body. Moves through the digestive tract, that's the whole system of digestion, by waves of peristalsis. That's the muscles contracting and kind of scooting the food along in blobs and mush all through the system. The liver and pancreas, again, those organs on the right of our body, we're facing someone, so it'd be the patient or the person's right side. So the liver up here and the pancreas just down below and the gallbladder kind of behind. Helps with the chemical digestion. A great wonder question would be, what are those substances? What are those chemicals? All right, where does mechanical digestion of food begin? You should hopefully know by now that mechanical, again, the chewing, crunching, as a hint, happens in the mouth. A little annoying bouncing ball. What are the finger-like projections that cover the folds of the small intestines, right? Those guys. You should know, hopefully, that's villi or villus if you're talking about a single one. Which of these is the muscular tube that connects the mouth to the stomach? And side note of why is it important that it's muscular? And that's going to be the esophagus. All right, what do you think now? Do you agree or disagree? Digestion begins in the mouth. What do you think? Hopefully you're thinking yes, because it does. We talked about that a couple times. Energy from food stays in the digestive system. In other words, it doesn't release it or share it to other body systems. Hopefully you're disagreeing with that, because it's not true. All right, and that gets us to lesson 3, which we'll talk about next time. Thanks, you guys. Have a good rest of your time, and thanks for watching.